Hello, everyone, and thank you very much for joining us today for Vertica Unified 2021. Today's breakout session is entitled An Architecture for Big Data, Supporting Journalism Through Transparency in Advertising. Now, this session is sponsored by Arrow, which is a platinum sponsor for this event. So thanks very much, Arrow, for sponsoring this event and sponsoring this session. My name is Steve Sarsfield. I'm on the partner marketing team here at Vertica, and I'll be your host for this webinar. Joining me are the crew from Index Exchange, and they will introduce themselves as part of the presentation. But before we begin, I encourage you to submit questions to the virtual sessions. Don't wait. Just enter your questions in the Q&A box on the right-hand side of the screen. Now, there will be a Q&A session at the end of the presentation, and we'll answer as many questions as possible during that time. Any questions we don't address, we'll do our best to fill in offline or answer offline. Now, this virtual session is being recorded, and you will be able to view it on demand this week. We'll send you a notification as soon as it's ready. Please stick around at the end of the session, and we'll give you a code so you can gain points and participate in our Analyze to Win competition to win prizes. So with all of that, now let's get started. First, I'd like to turn it over to Carl at Arrow for a brief introduction.
Thank you, Steve. Hello, everyone. Carl Fonseca here with Arrow Enterprise Computing Solutions. For those of you who are not aware of Arrow, we connect thousands of suppliers like Vertica with partners like Benchmark around the globe to unlock a world of potential for end customers just like Index Exchange. This particular Index Exchange opportunity was a true partnership in every sense. The Vertica channel team, led by Christina Nebel, brought the deal to Arrow. Arrow then engaged our value partner Benchmark Corporation, led by Mike Walker. Mike has built a committed Vertica practice, and it was just a natural fit with Benchmark's overall data, IoT, and analytics portfolio. Index Exchange, as the customer, really needed to modernize their analytics platform. And they also had to balance the needs of the business with the challenge of incurring additional costs in this current economic environment, especially brought about by COVID-19. Fortunately, Arrow Capital Solutions, our financing arm, was able to solve this challenge by providing flexible terms and payment options. Turns out coming up with the right financial solution is just as important as the solution itself. Thank you and congratulations to everyone who helped bring the benefits of Vertica to Index Exchange, especially Katie Bewley, Sean McGowan, and Christina Nebel from the Vertica channel team. Now over to Catherine from Index Exchange.
Good afternoon, everyone. My name is Catherine Strong, and I am a data and reporting product manager at Index Exchange. Today, I'm joined by my colleagues who will introduce themselves throughout the presentation. We're going to give you a bit of a background about how we are using Vertica as our primary engine for big data and how we use data to support digital publishers and independent digital media companies at Index Exchange. So when you think of big data or how someone would use Vertica, you may not necessarily jump to digital advertising or journalism or how they're connected. So to give you some context into what Index Exchange does, we're a global programmatic advertising exchange that helps premium publishers like the Globe and Mail and digital media companies like kayak.com or expedia.com sell their advertising space in real time. So online advertising can sometimes be a little bit taboo, but it's actually really, really critical in supporting journalism and independent media, because without advertising, a lot of our favorite content providers would cease to exist. This slide shows some of the publishers and media companies that we work with today to help monetize their advertising space. One of the reasons that I personally love working at Index is because I know that we're helping a lot of these companies survive and thrive, and they're all making our lives much richer with information and tools that we need to do things like book travel or buy products that we'd like. So today, about 70% of advertising dollars are spent on big tech giants. You can think people like, or companies like Google, Facebook, Amazon, but only about 40% of time spent on the internet are actually on those big tech platforms. So one of our goals at Index is to reroute advertising dollars back into publishers' pockets to support independent journalism and digital media. So you may be wondering, how exactly does programmatic advertising work? I'm going to give you a little bit of a 101 of how programmatic advertising works and one of the reasons why Vertica is so critical to our organization, because our data volume is so high. So on the slide here, you can see there's an example of a transaction chain before an ad is actually served to a user across different formats of media. So let's think web page, a mobile browser, in-app, or on CTV. So going over to the left-hand side of the screen, a brand like Lululemon would work with agencies to develop an advertising strategy. And part of that strategy is programmatic advertising. That's what we do at Index. So in order to facilitate programmatic ad buying, agencies use tech-enabled buying platforms called demand-side platforms, or DSPs for short. In this example, you can see that the DSP is named the Trade Desk. So then the auction occurs. Demand-side platforms bid on ad space from auctions that we, Index Exchange, conduct in real time. During this auction, the highest bid wins, and a Lululemon ad would be served to a user on a site like the Globe and Mail. To give you a sense of the scale of our business, here's a chart that I pulled this morning showing a 7-day rolling average of auctions run throughout this year. So we process over 200 billion auctions per day. And as you can see, we're continuing to grow. Every time a user is hitting a web page, an app, a CTV that we partner with, an auction's occurring, which is generating data that we're storing in Vertica. So I'm going to hand it over to Raman to give you a little bit of a deep dive into how our systems work.
Thank you, Catherine. Hi, everybody. I'm Raman Sarveria. I'm a data engineer here at Index Exchange, and I'm one of 3 that will be presenting to you today. My goal here is to kind of give you the lay of the land and hope that after I'm done talking, you'll kind of understand a bit more about our data pipelines and hopefully ramp up enough for the following 2 presentations. So without further ado, we'll jump into our data and scale. To start with, we are in 8 data centers located around the world. And within these data centers, we're running 6,000 plus Exchange servers. These Exchange servers are running those auctions. And from those auctions, we get about 100 terabytes of telemetry data collected every single day. That 100 terabytes is about 200 billion auctions, as Catherine just mentioned, or over 1 trillion bid requests to DSPs for those auctions every day. After flowing through our pipelines, we end up with about 25 gigabytes of heavily compressed and aggregated reporting data. This brings us to our architecture before Vertica. It's a bit much to ingest all at once, so we'll dive into this piece by piece. To begin with, the regional data centers. As I just mentioned, we have 8 regional data centers, and within these data centers, we're running 6,000 plus ad servers. These ad servers running auctions store that 100 terabytes of raw logs collectively across all of the nodes. In addition, we have 2 clusters. We have an ingestion cluster and we have our Hadoop cluster. This ingestion cluster is running a set of dedicated nodes where akka jobs are running. And these jobs, their sole purpose is to pull all of those raw logs from around the globe and to stage them into our Toronto data center, into this Hadoop cluster. And that brings us to the Hadoop cluster. This Hadoop cluster is the heart of our reporting, and we use it for 2 key purposes, our processing and our storage. In terms of processing, we're currently powered by Spark Scala jobs, and these jobs do everything from cleaning to transformation of our data sets aggregations of our data sets, custom one-off reporting jobs, and much more. In addition, our storage. We are petabyte scale storage, and we leverage the Hadoop distributed file system. Our HDFS cluster stores everything from raw logs to staged intermediate data that's passed in between these jobs, to configurations, finalized data sets, and much, much more. This HDFS cluster is our data lake. And then lastly, that brings us to our reporting vertical. We have two key products here. First being client audit logs, and the second being this reporting AWS. We'll think of this as our visualization platform. To first go into client audit logs is data as a product. Client audit logs are log level granular data sets, which you can think of as receipts. This enables us to give transparency to our clients such that they can understand exactly what is happening in all of the auctions that they participate in. And then lastly, this visualization platform. The visualization platform is constantly ingesting our aggregated data sets, and not only is it visualizing our aggregated data sets, but it enables our users to create custom reports off of those data sets. And this brings us to our product needs for Vertica. Well, to start with, we want to be able to control our own data again. As I just mentioned, that visualization platform is actually ingesting our aggregated data sets. In an ideal world, that data never leaves our metal. And we talked about how we have visualization and this very granular client audit logs, but we want to be able to bridge that gap. We didn't have SQL level access to that data, and we really just needed a data warehouse in between. Additionally, there was no way for customers to automate and schedule reports in a self-serve fashion, which will come up later in this presentation. And lastly, we want to be able to build and track insights on usage patterns. And this is what our architecture looks like now with Vertica. As you can see, there's now a warehouse vertical. In the far right, you can see three new boxes. We have reporting, as well as two BI tools in Looker and Redash. Okay, so how did we get here? Well, we started off with a proof of concept. We considered a multitude of solutions, but ended up narrowing it down to Domo, Snowflake, and Vertica. With these, we considered multiple AWS cluster sizes and a set of load and read queries. So in essence, we ran a performance comparison. And this led us to a few final deciding factors. The first, performance. It was within our service level objectives, and both Snowflake and Vertica were much better than our existing solution. Next, we had cloud versus on-premise. And one of the defining things here at IX is we truly believe in owning it ourselves and protecting our data. By keeping everything on our metal, it enables us to be truly efficient. We can understand everything that is happening in every square inch of our exchange and our data centers. And then lastly, we have lower cost. The licensing cost model, plus the fact that we'd be able to run our own commodity hardware, is a huge plus. So that brings us to our cluster configuration. We're running 3 different environments in our development, staging, and production clusters. In production, we are running 120 machines, which ends up being 480 terabytes of disk space, 2,400 cores, and just over 15 terabytes of memory. This cluster is very heavy CPU based in compared to disk space. And for our disk array, we are running a RAID 5. So we're using striping for performance and parity for redundancy. One thing to note on this is that 480 terabytes is 4 1 terabyte drives for each machine. So although we get 4 terabytes per machine, with a RAID 5 configuration, this knocks us down to about 2.5 to 2.8 terabytes of usable disk space. And that is all from me. Hopefully this helped ramp everybody up, and I will pass it along to Kevin. Thank you for listening.
Thank you, Raman. Hi everyone, my name is Kevin Boak and I am a data engineer as well here at Index Exchange. And I'm going to talk to you guys pretty briefly about the reporting system that we've stood up over the last year on top of Vertica. So let's jump into it. Okay, so first I want to go over some of the high-level architecture, basically just introduce some of the components that make up this reporting system. So first off, we see up here at the top, we have the Report Builder UI. And so this is the primary access point for our external clients. Basically, this gives them the ability to create their own reports, edit their reports. They can download reports through this UI. This is built into our existing Index Exchange user interface infrastructure. Now, behind that, we have the API itself, and this is where I've spent the majority of my time over the last year. And so our API serves a number of different purposes. On one hand, it serves all the calls coming in from the UI itself, but it also acts as a secondary access point for our external clients, some of our clients that are more comfortable with an API pipeline instead of using the UI directly. The API also acts as the primary access point for our internal clients. We have a lot of analysts and so on and so forth that use this system as well, and they have direct access through this API. Now, one of the key functionalities of our reporting system is the ability to schedule reports and to run these reports on a specific frequency. So when we were initially building this out, it crossed our mind to rebuild the wheel essentially and build out our own scheduling software. But at the end of the day, we ended up delegating this to third-party software, and we actually use Airflow 2.0 for all of our scheduling and as well as a queue. Now, behind the API and Airflow itself, we have MariaDB running in a Galera cluster, and so that's where all of the state is tracked. We have our HDFS storage layer where we store all of the reports. And then behind it all, we have Vertica as the data warehouse. Now, as well, not shown on the screen here, we run a few other tangential jobs as part of this system. We have a Redis cache between Vertica and the UI that stores a couple gigs of data that gets used on the UI a lot. As well, we're running a custom MySQL exporter as a Telegraph agent and pulling a lot of metrics from our API and pushing them to our InfluxDB cluster. So that covers the high level of it. So I want to talk a little bit about the actual scheduling workflow and what that looks like as part of this system. So our scheduling is cron based, as that's one of the things that Airflow understands. Now, the nice thing about this is we've abstracted away the actual cron from the clients. So we don't need our clients to actually understand how to schedule things with cron. So if you see up here on the top left, we have a few examples of what might be a schedule definition in a JSON object. And so we ingest that. We have a cron generator that basically parses that and builds out a cron schedule for these reports. And now by abstracting it away from the clients, it gives us the flexibility to distribute the processing of these reports over various times of the day, so there isn't these huge spikes in processing. So once we have this cron schedule, what happens? So our Airflow scheduler is going to kick off a reporting job. Now, this is a pod that runs in our Kubernetes cluster, and it's going to generate this report. So how does it do that? Well, the first thing it's going to do is it's going to reach out to our API. And the API is going to generate a SQL statement for this report. Now, it does that in 3 distinct steps. The first step, as we see here on the bottom right, is through the table abstractor, which basically builds out the base SQL. And Sriram's going to talk a lot more about how that works. The second aspect of this is the actual range generation. So if you consider a scheduled report that's running every hour, every day, the range of data over which that report runs is kind of like a sliding window, and that's what this range generation does, is it builds out the start and end times for each of those SQL queries. The third aspect of building out that SQL statement is actually applying the account level filters. So what this does is basically, this is what ensures that client A doesn't see client B's data. We have to apply these top level filters to all of the data so that clients can only see what they own. So once that SQL statement is generated, the reporting API is going to send that back to this report generation job. The report generation job is going to run that query against Vertica, and we are going to stream write those results directly from Vertica to our HDFS cluster. So I want to talk a little bit more about the range generation because it serves two purposes and exactly what it is. So if we see on the top left here, there's an example of what may be a range definition for a report. In this particular example, it's a report that's looking to get the previous 2 weeks of data plus the current week, and with a time zone specified. Now, the time zone that we store our data in is all in UTC, so if we need to do conversion, this would have to happen here. So with a range definition along with an execution time of a report, we can generate a start and end time of that report. Now, it serves two purposes. The first and simplest, as I alluded to earlier, was that it allows us to build out this SQL filter, which we see at the bottom. The second purpose, which may not be entirely obvious, is, as Raman mentioned, the data that we store in Vertica is already aggregated. Now, we aggregate our data to 3 different granularities. It's either aggregated by hour, day, or month. And depending on the range that we actually build out for this query, it allows us to select the most optimal level of aggregation for each query. Okay, so now that we've built out this file and we've stored this file on HDFS, what is it that we do with it then? And so the clients have a few options at this point. The first and simplest is every file that we generate for a client is available to download directly through our API or through the UI. So anytime a file is generated, whether it be a scheduled report or whether they run it manually, that file is going to be available for them to download. We do also offer 2 push methods of delivery at the moment, in email and S3. So for email delivery, we are going to pull that file from our HDFS cluster. We simply attach it to an email, and we send it through our IX email server. For S3, for larger files as well, because there's size limits on email. So for large files, we offer the ability to stream files directly to a client's S3 bucket. And so for that, we run a delivery job also in our Kubernetes cluster that takes that file from HDFS and streams it to an S3 bucket. Now, one of the cool things that we did for this is we never actually require clients to give us their S3 credentials. For security purposes, we wanted to use our own account credentials. So we actually generate account-specific S3 credentials for every bucket that we're going to upload to. And then we have the clients give access to our account as opposed to them having to give us their user and password, essentially. Okay, so that basically covers the scheduled reporting system. Now, there is one other workflow that I want to discuss, and that's the ad hoc workflow, as we call it. So being able to schedule reports to run on some cadence is super valuable, but a lot of clients also want to just make a report and run it right now. So we do also offer that functionality through our UI and through our API. And so what that looks like is very similar. A client can build out a report specification, whether it be in a JSON object for the API or through our user interface. And they can essentially just run that right away. And that's going to go through a very similar process. We're going to build out that SQL statement the same as we did for a scheduled report. We're going to query Vertica directly from the API, though, this time. And we're going to stream back a preview of that data right to the UI. So essentially instantly, a client can build a report, click run, and they are going to see the top N rows of that report. Now, if they decide that they want to export that file, they have that option. And when they click that button, we're going to run that report through our usual pipeline and we are going to generate the full file for them. We're going to store it on HDFS, just as with the rest of the files, and they can download that immediately. And so that gives them the two separate options. You either have the scheduled regular reports, or you can just build reports and run them right away. And so that there pretty much sums up the self-serve UI and API that we have built out on top of Vertica. And that, combined with the BI tools, Looker and Redash, is essentially the entirety of our reporting system. Thank you very much.
Thank you, Kevin. Hello, everyone. I'm Sriram. I'm a data engineer here at Index Exchange, and I'm going to talk about a cool thing that we built called the Table Abstractor. So what is Table Abstractor? Kevin had mentioned about reporting UI and how users can create their own reports, but the problem is, how do we translate what the users had selected on their screen to database queries that can be run against Vertica? So we needed a abstraction layer that would abstract the underlying schema or the columns from Vertica, and this service is what we call the Table Abstractor. This service has to understand what users have selected when creating their reports. It has to figure out where this data exists within Vertica, which of those data needs to be aggregated, and form a SQL query to give exactly what the user had requested. The reason why we need a self-service and a table abstractor will be very obvious if you look at this image. This picture shows the relations between a few of our important tables in Vertica. You can see how complex it can get, and we don't want our clients or our internal support team to have to learn these relations in order to get the data that they need. To start with the abstraction, we introduced this concept of fields. So the users of the UI or the API create reports by selecting the fields that they need. So fields represent a uniquely identifiable feature in our dataset. For example, it could be revenue or number of impressions, etc. Fields internally map to columns in one or more tables within Vertica. Fields can also represent calculations. For example, it could be a sum of two or more columns, or it could be conditional. And finally, fields can only be classified as dimension or a measure. This helps us to know which fields need to be aggregated and which of them are not. In this picture, you can see how the fields map to the columns, and those columns in turn map to the tables in the database. So when a user selects a field, we can always say which table contains that field. So let's say the user selects a bunch of fields when they are creating a report through the UI. How would we figure out what tables to use to get the requested data, and how would we generate a SQL? So we start by modeling the tables and the relation between them as a graph. So you can see the graph is not directional, it's not weighted, it's a simple graph. The nodes in the graph represents the tables, and the edges connecting the nodes contain information about how the tables are related. So it mostly contains foreign key information. To generate a SQL, we traverse the graph. Let's say a user has requested 4 fields, which means they have requested 4 columns from the underlying data warehouse, and we have to find the best combination of tables from which we can get the data for those columns. So we start to traverse the graph to find out which tables to use. We start from any node where we know at least one field exists. Let's say we start at table A and we find columns 1 and column 2 in table A. And then we start to traverse breadth first. So we first record this information as we found column 1 and 2. Then we move on to the next table, which is table C. Let's say we don't find anything over there. And then we move on to table D. And let's say we find the rest of the columns, which are column 3 and column 4, over in table D. We record that information as well. So we have found all the 4 columns right now, but we don't stop here. We also look for other combination of tables where the same information can be obtained from. So let's say we start from table B this time, and we find column 1 and column 2 over in table B. So we record that information. We start to traverse again. So we go to table E. Let's say we don't find anything over there. We go to table A. Table A, even though it contains column 1 and 2, which we already found in table B, so it doesn't. It is not of any value to us in this traversal. So we move on. We go to table F, and let's say we don't find anything there. We finally go to table H, and we find column 3 and 4 in table H. We record that information as well. Now we have 2 possible combinations that can give us the same data. So how do we choose which one to use? The way we do that is by comparing the combinations. First, we find the shortest path between the nodes. And for combination A and D, the direct path is the shortest path that connects table A and D. But you can see there is also a possible path through C, but we don't use that. But for table combination B and H, the shortest path is through table E, but there's also a path that is available through F, but like I said, we always take the shortest path. Now that we have got all paths, we next look for nodes in each path. The first combination, which is A and D, has 2 nodes, and the second has 3 nodes. We always choose the combination that has the fewest number of nodes. We do this to reduce disk I/O and also to join as few tables as possible. So in this case, we choose table A and table D. Once we have gotten our tables, finally we can go ahead and inform the SQL. We know what columns exist in A and D. So to form a SQL, first we start with select. We put in all the columns that we need, and because we already know which tables they come from, we use the appropriate prefixes. And then the from part, we put the root table where we started from, where we started the traversal from. And so we started from table A, and so the from part has table A in it. And then we left join with table D. And for the column information, we use the relation information from the edges of the graph and use that on the join condition. And then comes the where part, where we use any filter condition that the user has provided when creating the report. And then comes the group by. For group by, we use all the dimensions, all the fields that are dimensions that the user had requested. And then comes the having part, which has any measures on which user wants to filter on. Okay, and that's how we generate a SQL with Table Abstractor. Now, before we wrap up, I'm going to give you a brief overview on how we set up our Vertica cluster, some choices that we made during the setup, and our usage. As you can see, we are using 54 terabytes of queryable data within our cluster right now. We have approximately 30 concurrent sessions at any given time, and we're serving close to 70,000 queries per day on our production cluster with 800 loads per day. And this number is steadily growing, and we only expect it to go up. Let's look at some of the choices that we made during the initial stages of our cluster setup. Like Raman mentioned, we have 120 nodes with 40 cores, 128 gigs of RAM, and 2.5 terabytes of usable storage on each node. As you can already see, we have high CPU count when compared to memory and disk, especially considering that we run mechanical disks and not SSDs. And naturally, we wanted to leverage more CPU. So we heavily compress our data using Z standard compression. This saves disk space and makes us wait less on disk I/O. We favor CPU-heavy encodings like block-dict for our projections wherever we can apply. We have set up resource pools on a use case basis. For example, reporting system that we just discussed has its own pool. All IX employees have access to the data in our warehouse, so we set up a pool that runs ad hoc SQL query from our employees. The pools don't have a fixed memory, but have a maximum memory set. That means they all borrow memory from general pool as required, but they cannot borrow beyond a certain limit. We came up with a query budget and memory limits based on 6 months of usage data, and so that's how we came up with the limits for the pools. We use hierarchical partitions for all our tables, and we also collect table and partition statistics on regular intervals. In this picture, you can see the duration of all queries that ran against our production cluster for the past 3 months. As you can see, most queries complete in less than 5 seconds. Obviously, there are queries that take more than 20 seconds. Some of them can be improved, but some of them are just digging up too much data, and so they naturally take longer. And with that, I thank you so much for listening. You can contact any of us directly or on LinkedIn for any of the questions that you may have. What we presented throughout this presentation is the stuff that we work on a daily basis. If that interests you, head over to indexexchange.com/careers. We're hiring data engineers and a few other roles. Thank you so much.
Wow. Great. What a fantastic presentation. Thank you very much, team from Index Exchange. I really appreciate it. Let's get to these questions because I see a lot of questions in the Q&A section already. So hopefully we'll be able to get to all of them. Question number one, probably most popular question. What is the role of Kubernetes in the previous architecture diagram? And I think that question was asked fairly early on in the presentation. And I saw it throughout the presentation as well. Can you talk a little bit about how you're using Kubernetes in your architecture? Anyone want to take that?
Sure.
If you want.
Go ahead, Raman. Go ahead.
Okay, so in terms of that, Kubernetes is where we're going to be doing majority of our orchestration. In terms of Kubernetes, it's orchestrating our reporting API. It's also where Airflow is existent. So we are running a version 2.02 right now of Airflow in Kubernetes. It's where majority of our jobs are running. So our jobs are spun up through pods. But to kind of give you like the lay of the land, that's where kind of majority of our client side deployments are happening at our company right now. And that's through this internal Kubernetes cluster. I don't know if that's too high level. We can probably dig a bit deeper if we want, if there's more questions about it. But I think that might suffice.
It seems to me that a lot of people who are using Vertica and just in the world in general, the IT world in general, are thinking about Kubernetes and what the future of that is. I mean, is this something that you are slowly adopting as part of your platform, or are you guys all in?
Right. So we began adoption of it many years ago. We're actively trying to upgrade to some of the newer versions. We're looking forward to potentially running some more. So to put a little bit of context, this cluster that I'm talking about lives within our data center that we've spun up ourselves in Toronto area. But we're looking to expand that usage to potentially have edge Kubernetes clusters, such that, as I mentioned, we had 8 global data centers. We're looking into potentially using some of that extra rack space for these edge Kubernetes clusters, and that could do a lot for us in terms of, co-located routing for some of these APIs, the UIs that we serve out of them. We might be able to start doing some pre-aggregation of these logs and log data and pass that through Kafka streams instead of having it all in memory in our Toronto data center. A TLDR of that is we are, yes, continuing to move towards using Kubernetes more and more at our org. Yeah.
Great. And of course, Vertica is just announced that they are, spinning up Kubernetes capability as well, right? So that's part of version 11, and it's been part of the development stream that we've had for quite some time. Great. So let's talk about Eon mode. Are you using Eon mode on HDFS? Was the question. I know you have a lot of Apache Hadoop and HDFS out there for your data storage. Is Eon mode on HDFS in the cards? Anybody?
Sorry,
it's not
Raman
something
yeah, it's tough.
As far as I know, it's
group.
not something I have heard of us moving towards. I know Eon mode is one of the options that I read about for Vertica, but I don't believe it's something that we've looked into. At least not something that I'm aware of directly. One of the other guys may know more, but personally, I have not heard any whispers of Eon mode being something that we were looking into.
Okay, great. So the question about someone said that they saw a search box in the table abstractor, and maybe that was part of your presentation, Sriram, right? Did you build it using something like Elasticsearch?
So the search box, it probably would have been the UI screenshot that we had in the presentation. So users can, when selecting a field, when they want to select a filter for their report, so maybe they want to filter by like country or region or whatever, they also get to like type what they want to filter on, and so that's where the search box comes into play, I guess. So when you type in the search box, it drops down an autosuggest, and the data for the autosuggest is preloaded or cached in a Redis cluster, and so it's loaded from Redis as people type in, and is shown on the UI, and users can select one of the options that's shown via the autosuggest box. So I think that's what the autosuggest box is for.
So yeah, it's sort of built on top of a operational graph database, essentially Redis, right? So that's kind of interesting technology using there. Okay, cool. A little bit more on the table abstractor. This was something that you built versus bought, right? I know there are quite a bit of solutions on the market. So tell me a little bit more about that, Sriram. What was your decision about building?
So one of the main reasons is that not many products offer the exact thing that we were looking for, right? And so, yes, there are offerings in the market, but they either come with their own ecosystem. For example, Microsoft SSRS has something similar, but to use SSRS, then you'd have to bring in the complete tool suite that Microsoft offers, which was not an option for us. And we're going with Vertica anyways. And so we need something that works on top of Vertica and also gives us complete customization over how we want to form the SQL. So we had to go with this solution. So this gives us flexibility in terms of how we pick data from Vertica, how to optimize queries, and so on. And also, it also gives us the option to be more user-friendly to the application, because we now don't just expose the column names that is in the warehouse directly to the end users, which is what most of the tools that at least I saw, did. We give them readable readable names for very user-friendly names on the UI, which then maps to the underlying tables and columns. And we also have a lot of customizations like calculated fields, and we are also even thinking of bringing in views within Table Abstractor. Views doesn't necessarily exist in Vertica itself, but only exists within Table Abstractor. So we could do all sorts of customization with this approach.
No, that's great. Yeah, the customization is the key thing there for sure. Just overall, there was a question about business impact, and have you guys found any metrics or tracked any metrics that made a difference for your coworkers in terms of reporting and so on?
Yeah, so I can take this one. So our teams had pretty robust data access before, but it was through a third-party BA. It wasn't scaling that well with our organization due to our data volume. We're constantly having performance issues. So, it wasn't so much that we created new data access. It was more that we created a lot of speed and efficiency across our organization. So instead of logging onto our old reporting, folks could query data directly in Vertica and have an answer in seconds instead of minutes or hours, which was a huge efficiency across our organization. And as you saw on Sriram's slide, the majority of our queries were completed within 5 minutes. And previously, we had scenarios where we were loading dashboards for hours, and so it has just really created a lot of efficiency, mainly because our teams can just do their jobs a lot faster.
Yeah, Catherine, you went a little robot on me there. I don't know if it was just me, but you kind of sounded like Cylon from Battlestar Galactica a little bit, but I caught most of that, so it was good. Let's just take one more question because I know I have to wrap this up pretty soon here. Let's talk about the reporting API. Did you build or buy your reporting API? And talk a little bit about that. What's the story on how you visualize essentially?
Yeah, so thanks. So we've built the reporting API from the ground up. Essentially, we did use a template API, but that as well is built in-house here. So we have a number of teams. There's a lot of teams using Kubernetes and using various APIs, and so we do have essentially a template that we can build from. But we used that template and we've built out all of the reporting specific functionality on top of that directly into it. So there was we never looked at purchasing or anything like that. It was always the intention to build it up from scratch. We do have a little bit of experience previously working with other APIs for some of our other products, I guess, for client audit logs, as Raman mentioned, was one of the other products we offered. We have various APIs that we built for that. And so we took what we learned from that, along with knowledge throughout the rest of the company, and we built the reporting API from scratch. Now it still has a ways to go. It's in its infancy at the moment, but yeah, it's been built out entirely by the teams at KW.
Great. Okay, well, that's all we have in time for questions today for time. There's a couple questions left, so thank you for our audience for the great participation. And for those questions that are left, we're going to do our best to respond to you directly via email. Of course, our developers are in the developer lounge, so feel free to jump in and talk to them at any time. Of course, today's replay and event will be available in a PDF copy will be available on demand very shortly. Now, don't forget our Analyze to Win game, and the session code for our Analyze to Win game is Yorkshire Terrier. Okay, and so this really concludes the breakout session. Hope you have a great day and hope you can get in on that Analyze to Win game. Thank you very much.